Hi students. Now we explain the continuation of Memento design pattern. Now we see consequences. Consequences, it describes the results of whatever underlying this a pattern. The Memento pattern has several consequences and several benefits, and that liabilities whatever we are presenting use that. The Memento design pattern has several consequences here. Here we study about the 5 consequences. The first one is preserving encapsulation boundaries. Preserving encapsulation boundaries in the sense, in Memento design pattern, we need to just avoid exposing information. Avoid exposing information that only an originator should manage, but that must be stored, but that must be stored nevertheless, so outside of that particular originator. So the Memento design pattern shields other objects from potentially, we say that should be a complex originator internals, and thereby we are preserving the encapsulation boundaries. So we are preserving that encapsulation boundaries. Okay, this pattern shields the other objects potentially complex from the originator internal state, how it represent. And coming to the second one, it simplifies originator in the sense, in other words, we should say encapsulation preserving design. Originator keeps the versions of internal state that clients have to be requested. So all the storage management burden on originator, we should have having some clients how to manage the state. They ask for how to simplify the originator, and just we need to keep clients from having to notify the originators when they are when they are to be done. Okay. And coming to the third consequence, that is nothing but using mementos might be expensive. Yes, exactly. We have to be using mementos. It might considerable if originator must copy a large amounts of information we need to store in the memento, or just if we can say, if the clients create and return memento to the originator oftenly, unless we should keep encapsulating and restoring the originator state, it's in very cheap way. So the pattern might not be suitable or appropriate, we can say. See here the discussion of incrementality in the implementation section. Okay, we discuss in the implementation section in clear cut way. And coming to the fourth one, consequence, defining narrow and wide interface. Yes, exactly. It may be a very difficult in some languages to make sure that only the originator can access the mementos state. Okay. And coming to the fifth consequence, that is hidden cost in caring for mementos. Hidden cost in caring for mementos in the sense, a caretaker is very responsible for delegating the memento, just to take care of. So however, the caretaker has no idea. It has no idea how much state is in the memento design pattern caring. So hence, otherwise the lightweight caretaker, it might incur to store large storage cost whenever we need to store it in memento design pattern. Okay. And coming to the implementation section, here are two issues we need to consider when we are implementing the memento design pattern. The first one is nothing but language support. Here mementos have two interfaces. First, a wide one for originators and a narrow one for other objects. So typically we need to see some idea about that implementation language. It will support two levels of static protections. Let us see this in advanced data structure C++. Lets you do this might be making the originator as a friend of memento design pattern, and making this memento a wide interface. It should be private. So So only the narrow interface should be declared public. Okay, this is the concept of language support. And coming to the second one, that is nothing but storing incremental changes. Storing incremental changes in the sense, whenever the mementos get created and passed back to their originator in a predictable sequence. So then the memento can save just the incremental change for storing purpose to the originator's internal state of its representation. So for example, we need to study undoable commands in a history list. Undoable commands in a history list, it can use mementos to make sure that commands are restored to their exact state whenever they are undone command. So the history list defines a specific order in which commands can be undone and redone. Okay, undo operations and redo operations. That means mementos can store just the incremental change that a command makes rather than the full state of every object whatever they affect. So in the motivation example given earlier, we seen the constraint solver object, it can store only those internal structures that change to keep the line, how we are constructing that, how we are connecting the rectangles, as opposed to storing the absolute positions of these particular objects. Okay, this is the example for storing incremental changes. Okay, and coming to the known uses, what are the present real life examples of in the real world of this memento design pattern? Coming to this, UniDraw supports connectivity through its constraint solver class. So in Dylan collection, just we need to provide an iteration interface that reflects the memento pattern. So we need to suppose to have the notion of a state object which is a memento that represents the state of the iteration. So just we need to create initial state and returns an initialized iteration state object for the collection purpose. So advances the state object to the next position in the iteration section, and we need to say it should be very effectively increments the iteration index. So is done operation function, it returns true if next has advanced it beyond the last element in the collection. So the correct item dereferences the state object and just returns the element in the collection to which it refers. Okay, and next we have to be returns a copy of the given state object. The memento design pattern based iteration interface acts as an intermediary. It has two interesting benefits. The first one is nothing but multiple state can work on the same collection, and the second one, it does not require a breaking collections encapsulation. Just we need to support that iteration. So the memento is only interpreted by the collection itself. The memento is only interpreted, so no one else can access to it. And coming to the core constraints, QoCA constraint solving that toolkit, how to store that incremental information in memento design pattern, how those clients can attain a memento that should be characterizes the correct solution to a system of constraints or conditions. So here the memento contains only those constraint variables that have changed since the last solution. So mainly, usually only a small subset of the solver's variables changes for each new solution. So this subset is enough to return the solver to the preceding solution. So we are reverting to earlier solutions whatever we need to require the restoring mementos from the intervening solutions. So hence you can't set the mementos in any order. And coming to the QoCA, it relies on a history mechanism, whatever we revert to the particular earlier solutions. Okay, and coming to the related design patterns of memento design pattern. This memento design pattern comes under the category of behavioral design pattern. Here there are two related patterns of memento design pattern, that is command design pattern and iterator design pattern. Coming to the command design pattern, for undoable operations, the commands can use mementos, how to maintain and how to handle those states. And coming to the iterator design pattern, as described earlier, the iterator design pattern, mementos can be used for iteration. Mementos can be used for iteration. Okay, this is the concept of memento design pattern. Okay, ma, thank you up to now.